When we're looking at a set of numbers, it's hard to really tell what's going on, especially if it's a really big set of numbers, many numbers in it. And so a lot of times we'll want to craft a distribution. We'll want to look at the distribution of values. So let's talk about what that means. Imagine that I was rolling a die, a six-sided die. Actually, I did this to generate these numbers. I rolled a die 10 times, and I got 2, then 1, then 3, then 5, then 6, then 5, then 6, then 1, then 2, then 4. Sometimes I get the same number more than once. Sometimes the number only appears once. When you're looking at these numbers, it's hard to really tell what's going on. But I can make a distribution, here what we would call a frequency distribution, where I look at how many times each number got rolled. 1 got rolled twice, 2 got rolled twice, 3 and 4 only once, and 5 and 6 twice. So I can see the distribution of outcomes that resulted from rolling this die. This is a distribution. It helps us visualize what's going on in the data. Of course, I only did 10 rolls, and so I have this kind of wonky looking distribution. Of course, we know if I rolled that die an infinite number of times, I would get even results for every outcome, if it's a fair die. So we could chart that as well. There are 6 possible outcomes, 1, 2, 3, 4, 5, and 6. As n, the number of rolls, goes towards infinity, then we would expect the number of times we see each one of the die faces to be the same as each other. Whatever n is, if I roll it 1,000,000 times, then 1/6 of a million is how many times I would expect to see a 1, and also how many times I would expect to see a 2, or a 3, or a 4, or a 5, or a 6. This is what we would call a uniform distribution, because each outcome is equally likely as each other outcome. But that's not always the case, and sometimes charting a distribution helps us see that that's not the case. So what if I rolled 2 dice and I added the numbers together? So if I rolled and I got a 1 and a 1, they would add to 2. If I rolled and I got a 1 and a 2, they would add to 3. Or a 2 and a 1, they would also add to 3. And you can see that each outcome, each sum, is not as likely as the others. 7 is the most likely outcome. That's the mean and median of this distribution. 7 is the most likely outcome of rolling 2 dice and adding the results together. And then 6 and 8 are the next most likely, and 5 and 9 are the next most likely, and then 4 and 10, and 3 and 11, and then 2 and 12 are pretty unlikely compared to the others. So you can see here a distribution that shows what we call central tendency, that the frequency of seeing certain observations increases as we move towards a certain value. That basically the outcomes are bunched towards a certain central value. They're distributed closely around that. So this distribution is one where the mean tells us a lot about what's going on in the distribution. Whereas the uniform distribution, the mean doesn't tell us that much, and we would expect a pretty high standard deviation for that compared to this one. So distributions help us understand what the data looks like, what the possible outcomes are, and how likely those outcomes are.